Hello dear students, our today's topic is barbital, which belongs to the therapeutic category of sedative and hypnotic drugs. This is the structure for barbital. Now we go for the IUPAC nomenclature of this compound. For nomenclature, we will number this heterocyclic ring first. So this nitrogen will be number 1, this will be 2, 3, 4, 5 and this will be number 6. For nomenclature, we will name this compound by 3 ways. Just look how we go for the nomenclature. Now this portion, this whole portion is called as barbituric acid. So in barbituric acid at position number 5 we have presence of 2 ethyl groups. So the name of this molecule will be 5,5-diethyl barbituric acid. So this is simply considered as the derivative of 5,5-diethyl derivative of barbituric acid. Now 2 more ways are there. This heterocyclic ring is considered as the saturated pyrimidine ring. So as per the pyrimidine, we will write down the name as 5,5-diethyl. The basic heterocyclic nucleus is pyrimidine. 2,4,6, 2,4,6, 1H, 3H, 5H trion. As we can see that there is presence of 3 oxo groups at 2, 4 and 6 position. So we write it 2, 4, 6 trion. Now one more way is that we can write the nomenclature as 5,5-diethyl diazine. The 2 nitrogens are at position number 1 and 3. So we call it 1,3 diazinan. On position number 2, 4 and 6 there is 3 oxo groups. So simply it is 2, 4, 6 trion. So all these names are the IUPAC names for the barbital. This drug belongs to the therapeutic category of sedative hypnotic drug. This drug have its action on GABA A receptor, where it facilitates the binding of GABA, the inhibitory neurotransmitter, on this GABA A receptor, due to which there is decrease in the arousal activity. Due to such kind of activity, the barbital find its use as sedative and hypnotic drug, and at one time it was a very popular sleeping aid which was used in treatment of insomnia. So let's look at synthesis of this compound. Now, if we look at the structure, we find that there is the amide linkages, CONH and this CONH. So dear students, just do one thing, just break this bond from here. So when this portion is broken down, we will arrive at two very important starting material for synthesis of this compound. Now this portion, this one comes from urea, that is NH2CO NH2. Now this portion is simply written as this way. I told you in my previous video that whenever a bond between a carbon and the heteroatom like nitrogen oxygen is broken down, we always have to put a hydrogen with the heteroatom, and we always have to put leaving group with the carbon. So we will put leaving group with this carbon. So we will added the ethoxy group over here, ethoxide ion, which is very important leaving group. So what we get? We get these two starting materials, this one and this one. This is called as urea, and this is called as diethyl malonate. This is the diethyl ester of this dicarboxylic acid, which is called as malonic acid. So we will write it diethyl malonate. But on this second carbon, there is presence of these two ethyl groups. So this malonate is called as 2,2-diethyl. So our starting material is diethyl, then 2,2-diethyl malonate, which has to be reacted with urea. Now the reaction has to be taken place in presence of solvating mixture. One very important point is that this alkoxy group is ethoxy group, C2H5O. So the solvating mixture has to be used like this, C2H5O minus Na plus, which is called as sodium ethoxide, and we have to use its another part, the ethanol. So due to presence of this ethoxy group, we will use this solvating mixture, sodium ethoxide and ethanol, so as to minimize the number of byproducts. When this malonate react with urea, we will get a very familiar reaction. This nitrogen attack on this carbonyl carbon, and this nitrogen will attack on this carbonyl carbon. This reaction is nucleophilic acyl substitution reaction. The ethoxy group, these two ethoxy groups and these acidic protons, this hydrogen and these hydrogens which are attached with this nitrogen are acidic protons. So the ethoxide ion and this proton will be liberated out as ethanol. So there is liberation of two ethanol molecules. When the ethanol molecules are liberated out, this carbon will make a bond with this nitrogen to give us a cyclic product. So dear students, we will get this product here. This product is called as barbital. The barbital is in the tautomeric form with its one of the structure. Now we can see that the the hydrogen on this nitrogen may migrate over this oxygen to give us a tautomeric product. So when this migration takes place, we will get formation of this compound, in this structure. You can easily see that this hydrogen is migrated from this nitrogen to this oxygen. So by this migration, the double bond will be generated between the nitrogen and the carbon, and there is a single bond between the carbon and oxygen. Now, due to presence of this hydroxyl group, this compound is acidic in nature. So when this reacted with a base like sodium hydroxide, there is a acid-base reaction. There is removal of water molecule, hydrogen from here, and this hydroxide combine to form the water molecule, and we get formation of this very important salt, which is called as barbital sodium. Dear students, you are observing here is the salt formation. It is called as barbital. The salt formation is with the sodium ion, so it is barbital sodium. So when the salt formation takes place, the compound will become polar in nature, and thus we can have the water solubility. So this compound may be formulated into the oral dosage forms. So that is all about the synthesis and the informations about barbital. Thanks for watching the video. Please like it, share it, and don't forget to subscribe. Thank you.